Examples 8 and 9 both involve the Pythagorean theorem, right triangle. Anytime you see a right triangle, this is the requirement to use the Pythagorean theorem is a right angle. Right? In this chapter, we're going to be solving right triangles, which involves finding the missing sides and missing angles. For today, we're just going to be finding missing sides with the Pythagorean theorem. Very soon, we're going to be finding missing sides in right triangles using trigonometry, missing angles also using trigonometry. And then as we continue on into the chapter, we're going to get to non-right triangles, and there's techniques in trigonometry to find missing sides and missing angles in those also. As you get away from right angles, the problems become more challenging, but just know that there's a lot of, in trigonometry, for lack of a better explanation, trigonometry is the advanced study of triangles is what it is. So we do a lot of triangle work in trigonometry. That's what's happening here. So in this case, since we do have a right angle, the missing side here we're called x. What you need to do is diagnose when you look at the right angle. There's two sides that are legs and one side that's a hypotenuse. It's important that you identify what each thing is. So the two sides that create the right angle are called legs. So 36 is a leg and 15 is a leg. The side opposite the right angle is called the hypotenuse. That's what they decided to name the side opposite the right angle. It's called a hypotenuse. Weird word, but it is what it is. So just know that when I say hypotenuse, that's what I'm talking about, the side opposite the right angle. And the Pythagorean theorem says leg 1 squared plus leg 2 squared equals hypotenuse squared. It doesn't matter which legs 1 and 2. So specifically here, 15 squared plus 36 squared equals x squared. And it's very important, leg squared plus leg squared equals hypotenuse squared. That order matters. Make sure the hypotenuse is all by itself, the legs are together. You don't always get two legs. Sometimes you get a leg and a hypotenuse. Make sure you put things where they belong in the formula. Grab our calculator to evaluate these squares. 15 squared is 225. That's one we should know. 36 squared is not as common, so let's...
1,296.
Thank you, Ashley. 1,296, that equals x squared. So you square both numbers, then you add them together, 1296 plus 225, which is 1,421.
You typed it wrong.
Yeah.
1,000, oh, one,
It should be
Oh.
1,500.
1,521, thank you, 1,521 equals x squared. All right. 1296 instead of 1196, so plus 100, 15. All right, so x squared equals 1521, so that means x equals the square root of 1521. So once you get this point, x squared equals number, x is going to equal the square root of that number. So the square root of 1521 is 39. If that happened to come out to a decimal answer, round to a couple decimal places, unless they specifically say round to this number of digits. All right? Sometimes they come out to nice, pretty whole number answers, though. So again, there's a missing hypotenuse. Pythagorean theorem is going to be used. In general, any right triangle problem you ever look at, if you know two of the three sides, the Pythagorean theorem can always find the third side every single time. So when you see a right angle, put that at the top of your list of things to look for. Can I use the Pythagorean theorem? Do I have enough information to use it?